Welcome to our deep dive into the concept of resistors. In this video, we'll explore what resistors are, why they're essential in electronics, and how they function within a circuit. Whether you're a beginner or just brushing up on your knowledge, understanding resistors is key to mastering electronics. Let's start by looking at the basic definition and purpose of a resistor, setting the stage for a journey through their types, uses, and significance in everyday devices. Resistor is a passive electrical component that limits or regulates the flow of electrical current in a circuit. It's one of the most fundamental building blocks in electronics. By providing resistance, it helps control voltage and current to protect sensitive components and ensure circuits function as intended. Resistors come in various shapes and sizes, but their core function remains the same: to oppose the flow of electric current. Resistance is the property of a material or component that opposes the flow of electric current. The unit of resistance is the ohm, symbolized by the Greek letter omega omega. In a circuit, resistance determines how much current will flow for a given voltage. High resistance means less current, while low resistance allows more current to pass. This simple principle is at the heart of how resistors control and manage electrical energy. Resistors are used in circuits for several important reasons. They can limit the amount of current flowing to sensitive components, divide voltages, and even help generate heat in some applications. Without resistors, circuits could easily become overloaded, leading to damage or malfunction. Their ability to precisely control current and voltage makes them indispensable in everything from simple gadgets to complex electronic systems. Resistors come in many shapes and sizes, but the most common type is the cylindrical, color-banded resistor. These bands indicate the resistor's value and tolerance. Other types include surface mount resistors, which are tiny and rectangular, and wire wound resistors, which are often larger and used for higher power applications. Despite their differences in appearance, all resistors serve the same basic function in a circuit. When an electric current passes through a resistor, the resistor opposes the flow, causing a voltage drop across its terminals. This process converts some electrical energy into heat. The amount of resistance determines how much current can flow for a given voltage, following Ohm's law. This simple yet powerful principle is the foundation of countless electronic devices and systems. Ohm's law is a fundamental equation in electronics, stating that the current through a resistor is directly proportional to the voltage across it and inversely proportional to its resistance. The formula is I equals VR, where I is current, V is voltage, and R is resistance. This law helps engineers and hobbyists alike calculate the right resistor values for their circuits, ensuring everything works safely and efficiently. There are several types of resistors, each designed for specific applications. Fixed resistors have a set resistance value, while variable resistors like potentiometers can be adjusted. Other types include thermistors, which change resistance with temperature, and photoresistors, which respond to light. Choosing the right type depends on the needs of your circuit and the environment in which it operates. Fixed resistors are the most common type and have a resistance value that does not change. They are used in countless electronic devices to set current and voltage levels. These resistors are reliable, cost-effective, and available in a wide range of values and power ratings. Their simplicity makes them a staple in both professional and hobbyist circuits. Variable resistors, such as potentiometers and rheostats, allow you to adjust the resistance in a circuit. This makes them perfect for applications like volume controls, light dimmers, and tuning circuits. By turning a knob or sliding a control, you can change the resistance and consequently the current or voltage in the circuit. This flexibility is invaluable in many electronic designs. Thermistors are special resistors whose resistance changes with temperature. They are widely used in temperature sensing and control applications such as thermostats and electronic thermometers. There are two main types: NTC negative temperature coefficient, where resistance decreases as temperature rises, and PTC positive temperature coefficient, where resistance increases with temperature. Photoresistors, or light-dependent resistors (LDRs), change their resistance based on the amount of light they receive. They are commonly used in light-sensing circuits such as automatic streetlights and alarm systems. When exposed to more light, their resistance drops, allowing more current to flow. This unique property makes them essential in many automation and sensing applications. Most fixed resistors use color bands to indicate their resistance value and tolerance. Each color represents a number, and by reading the bands in order, you can determine the resistor's value. This system allows for quick identification and is standardized across the electronics industry. Learning to read these codes is a fundamental skill for anyone working with electronics. Every resistor has a power rating, which indicates how much electrical power it can safely dissipate as heat without being damaged. Exceeding this rating can cause the resistor to overheat and fail. Common power ratings include 1.8 watt, 1.4 watt, and 1 watt, but higher ratings are available for demanding applications. Always choose a resistor with an adequate power rating for your circuit. Tolerance is a measure of how much a resistor's actual resistance can vary from its stated value, usually expressed as a percentage. For example, a 100 ohm resistor with a 5% tolerance could actually be anywhere between 95 and 105 ohms. Lower tolerance resistors are used in precision circuits, while higher tolerance is acceptable in less critical applications. When resistors are connected end-to-end in a series, their total resistance is simply the sum of their individual resistances. This configuration is often used to achieve a specific resistance value that may not be available as a single resistor. Series connections also help distribute voltage drops across multiple components. Connecting resistors in parallel provides a way to decrease the total resistance. In this arrangement, the total resistance is always less than the smallest individual resistor. Parallel connections are useful for increasing current capacity and creating specific resistance values. This method is commonly used in power distribution and balancing circuits. Resistors are everywhere in electronic circuits. They set bias points in amplifiers, limit current to LEDs, and form voltage dividers for sensors. Their versatility and reliability make them a go-to component for engineers and hobbyists alike. Understanding how to use resistors effectively is crucial for designing robust and functional circuits. A voltage divider is a simple circuit that uses two resistors to produce a specific output voltage from a higher input voltage. This configuration is widely used in sensor circuits, reference voltage generation, and signal conditioning. By choosing the right resistor values, you can create precise voltage levels for various applications. One of the most common uses for resistors is to limit the amount of current flowing through a component, such as an LED. By placing a resistor in series with the device, you can ensure it receives the correct amount of current, preventing damage and extending its lifespan. This simple technique is fundamental in circuit design. Pull-up and pull-down resistors are used to ensure that digital inputs are at a defined logic level when no active signal is present. Pull-up resistors connect the input to a high voltage, while pull-down resistors connect it to ground. These simple components help prevent erratic behavior and false triggering in digital circuits. In some applications, resistors are used intentionally to generate heat. For example, in electric heaters, toasters, and certain sensors, the heat produced by current flowing through a resistor is harnessed for a useful purpose. These resistors are designed to handle higher power and are built with materials that can withstand elevated temperatures. Resistors are key components in electronic filters, which are used to block or pass certain frequencies in a signal. By combining resistors with capacitors or inductors, you can create low-pass, high-pass, bandpass, and bandstop filters. These circuits are essential in audio equipment, radio communications, and signal processing. Timing circuits often use resistors in combination with capacitors to create delays or oscillations. The resistor controls how quickly a capacitor charges or discharges, setting the timing interval. This principle is used in clocks, timers, and oscillators, making resistors vital for precise time-based functions. Resistors can be made from various materials, including carbon, metal film, wire wound, and even ceramic. Each material offers different characteristics in terms of stability, noise, and power handling. The choice of material affects the resistor's performance and suitability for specific applications. Surface mount resistors are tiny rectangular components designed for automated assembly on printed circuit boards (PCBs). They save space and allow for high-density circuit layouts. Despite their small size, they offer the same functionality as traditional resistors and are widely used in modern electronics. Wire wound resistors are made by winding a metal wire around a ceramic core. They are capable of handling high power and are used in applications where heat dissipation is critical. Their construction makes them more robust and precise, but they are generally larger than other types. Metal film resistors are known for their accuracy and stability. They are made by depositing a thin metal layer onto a ceramic rod. These resistors are commonly used in precision circuits where consistent performance is required, such as measurement equipment and audio devices. Carbon composition resistors are made from a mixture of carbon powder and a binding material. They were widely used in the past but are less common today due to their higher noise and lower stability. However, they are still found in some vintage electronics and applications where their unique characteristics are needed. Resistor networks are packages containing multiple resistors in a single unit. They are used to save space and simplify circuit design, especially in digital electronics. These networks can be configured in various ways, such as arrays or ladders, to meet specific circuit requirements. Precision resistors are manufactured to have extremely accurate resistance values and very low tolerance. They are used in measurement instruments, calibration equipment, and other applications where accuracy is paramount. Their high quality ensures reliable and repeatable performance. Not all resistors have a constant resistance. Nonlinear resistors, such as varistors and thermistors, change their resistance in response to voltage or temperature. These components are used for surge protection, temperature sensing, and other specialized functions where variable resistance is needed. Resistors can fail due to overheating, excessive current, or physical damage. Common failure modes include open circuits where the resistor no longer conducts and short circuits where it loses resistance. Understanding these failure modes helps in troubleshooting and designing more reliable circuits. Testing a resistor involves measuring its resistance with a multimeter. This simple check can confirm whether a resistor is functioning correctly or has failed. It's an essential skill for anyone working with electronics, ensuring that circuits operate as intended and troubleshooting is efficient. Selecting the right resistor for your circuit involves considering resistance value, power rating, tolerance, and physical size. Each factor affects the performance and reliability of your design. By understanding these parameters, you can make informed choices that lead to successful and safe electronic projects. Resistors must be chosen to withstand the environmental conditions they'll face, such as temperature, humidity, and vibration. Special resistors are available for harsh environments, ensuring long-term reliability and performance. Always consider the operating environment when designing circuits. Resistors are found in almost every electronic device you use daily, from smartphones and computers to household appliances and cars. Their role may be hidden, but they are essential for the safe and efficient operation of modern technology. Next time you use an electronic device, remember the humble resistor working behind the scenes. Concept of resistance and the invention of resistors have a rich history. Early resistors were made from simple materials like graphite and clay. Over time, advances in materials and manufacturing have led to the precise, reliable resistors we use today. Understanding this evolution helps appreciate the importance of resistors in technological progress. Modern resistor technology continues to evolve, with new materials and manufacturing techniques improving performance, reliability, and miniaturization. Innovations like thin-film and thick-film resistors have enabled the development of smaller, more efficient electronic devices. The future promises even more advancements as technology progresses. Sustainability is becoming increasingly important in electronics design. Manufacturers are developing resistors with environmentally friendly materials and processes. Recycling and proper disposal of electronic components, including resistors, help reduce environmental impact and promote a greener future. Some common mistakes when working with resistors include choosing the wrong value, exceeding the power rating, or misreading color codes. These errors can lead to malfunctioning circuits or even damage. Double-checking your calculations and understanding resistor specifications can help you avoid these pitfalls. There are many resources available for learning more about resistors, from textbooks and online courses to hands-on kits and simulation software. Exploring these resources can deepen your understanding and help you become more confident in designing and troubleshooting electronic circuits. In advanced electronics, resistors play critical roles in analog and digital signal processing, power management, and precision measurement. Their reliability and versatility make them indispensable in everything from medical devices to aerospace systems. Mastery of resistor concepts is essential for any advanced electronics engineer. As electronics continue to evolve, so will resistor technology. We can expect even smaller, more efficient, and environmentally friendly resistors in the future. Ongoing research and development promise exciting innovations that will further enhance the performance and sustainability of electronic devices. Summary: resistors are fundamental components that control current, divide voltage, and protect circuits in countless electronic devices. Understanding their types, functions, and applications is essential for anyone interested in electronics. As technology advances, resistors will continue to play a vital role in shaping the future of electronic design. Thank you for joining us on this journey through the concept of resistor.